4.3, how derivatives affect the shape of a graph. Essential question, what does the second derivative reveal about the graph? Let's take a look at this picture. Notice that the derivatives are all positive, but in this case, the derivative is increasing. The slope of the tangent lines are getting greater and greater. When this happens, we say it's concave upward. All the slopes here are also positive, but they're getting less and less positive, so we say the first derivative is decreasing, and when that happens, the curvature is what we call concave down. So by definition, if the tangent lines are above the curve, we say concave down. If the tangent lines are below the curve, we say concave up. When a second derivative is greater than 0, so when it's positive, we say that it's concave upward. When the second derivative is negative, we say it's concave downward. So this is concave upward. The second derivative is positive. Here's concave down. This is the second derivative is negative. There's a point at which it stops being concave up and concave down, and that point is called a point of inflection. All right, the second derivative test is a test that will reveal local max and local min. And what the test says is if the first derivative is equal to 0, in other words, you have a horizontal tangent line, and the second derivative is greater than 0, which means it's positive or concave up, we call it a local min. Again, here's the horizontal tangent line, and at C it's concave up, so we're going to get a min. If we have a horizontal tangent like this, and the second derivative is negative, that means it's concave down, then we have a max. Let's take a look at using the second derivative test. Right here I have taken the derivative, I found my critical points, and I know at this point that the first derivative is equal to 0, which means I have a horizontal line tangent. I'm going to look at my second derivative, which is going to be 0, so this tells me nothing. I'm going to look at the second critical point, which I know is a horizontal line, horizontal tangent, and then I'm going to test out 3, and I see that it is 36, which implies by the second derivative test, that this is a minimum. It's concave up, and so therefore we have a minimum value. So I'm going to draw a little minimum right here on my curve, right here at 3, because I know it's at 3, negative 27. All right, now I'm going to take a look at the second derivative and look at its sign change to see concavity. Now, when it's less than 0, I've already put it in factor form. I know I'm going to have a negative and a negative, so this is going to be positive. And then from 0 to 2, I know I'm going to have a positive and then a negative, which is negative, and then both of these are going to be positive. So this is telling me concave up, concave down, and concave up. All right, so that means right when I get to 0, 0, I am going to concave up, and this is a point of inflection at 0, 0. Then I'm going to go concave down, and then at this point of inflection at 2, I'm going to go concave up. And so that's kind of what the graph is going to look like. Now, so I've talked about concavity, I've talked about points of inflection, and my local max and local min. All right, let's go ahead and take a look at answering all these questions. We have done increasing and decreasing before. We have done local max and local min, and they want us to reveal concavity and points of inflection. All right, so I have my derivative. I have it in factored form, and I have my critical points right here. and I've graphed them, and so now I'm just going to take a look at my signs. So when x is less than -3, I know that I'm going to have negative and negative, so this is going to be a positive. And then this is going to be between -3 and 2, I am going to have a positive and then a negative, so that'll be negative, and then greater, that'll be positive and positive. So now I can talk about increasing and decreasing. So I know from -infinity to -3 and from 2 to infinity, f is increasing, and that's because the first derivative is positive. And the interval from -3 to 2, f is decreasing because the derivative is negative. So now I know about increasing and decreasing. I have some increasing happening, decreasing happening to 2, and then increasing happening. So let's take a look at the second derivative. I go ahead and set it equal to 0, and this is a point of inflection if the derivatives change. So less than -1/2, I am going to get negative values, and greater, I'm going to get positive values. So this is telling me I have concave down here and concave up here. All right, so I'm going to use all of this information to help myself graph. So I know that I'm going to be increasing. This is concave down, decreasing, concave down. At this point, I am going to start changing my concavity, and I'm continuing down, but now I'm kind of going up, and then here's my min, and then I go up here like this. Okay, so this is telling me I have a maximum, and this is my minimum. So I can say that this is my max, and that's because the first derivative changes from positive to negative, and this is going to be a min because f prime changes from negative to positive. And then I have my local max, local min. I've done my increasing and decreasing concavity. So from -infinity to -1/2, it is concave down, and from -1/2 to infinity, it's concave up. And my point of inflection, this is my point of inflection, and that's where the sign changes. Okay, your turn. Stop the screencast and see if you can answer all these questions, and then start it up again to see your answer. And there's a lot of work here. You've got to take your derivative, you've got to take a look at your sign change here. That'll reveal increasing and decreasing. It also increases max and talks about max and min. I think I looked at the second derivative, but you could have looked at the first derivative test if you wanted to. And then the second derivative, I have a sign chart here, and it's revealing concavity here, my point of inflection. And you only have a point of inflection if the sign changes. Otherwise, if the sign doesn't change in the second derivative, you don't have a point of inflection. And in summary, this is what we have.